Welcome. I'm Elliott Harold. This is Effective Unit Testing. Welcome. I hope everyone can hear okay. It sounds like the mic is on. I, however, cannot see okay. There are these incredibly bright lights going right into my eyes. So if you want to like me to see you, you need to come up to the front. We have plenty of space. Currently, where do I come from? What's my experience with testing? I've done a number of things over the years. Right now, I'm tech lead of Google's cloud tools for Eclipse. Currently has about 70% test coverage as measured by Jacoco. I honestly think that's a little low. I'm working on bringing that up. Should be higher. I'm also the developer of XOM, which is an independent library I did some years before I joined Google. That runs about 99% test coverage. I'm very proud of that. I mean, really, you're down to just the only things that aren't covered are like catch blocks for runtime exceptions that can't actually happen, but you have, or checked exceptions can't actually happen, but you have to put them in there anyway just to make the compiler happy. So that was written test first, and that worked really well. I'm also the current maintainer of the Jackson XPath library. I actually got started on that library because it didn't have such great test coverage. I was using it. I started submitting tests to it. I often discovered when I started writing tests for the classes that there were bugs nobody had noticed, which is often the case with untested code. And because no good deed goes unpunished, I'm now the maintainer of the project. I've written a few books over the years, none yet on testing, but I've got a few years yet to do that. This is not going to be an introductory talk. I'm not going to give you a lot of details about the syntax of JUnit or how you write your setup methods or your fixtures or anything like that. What I want to talk about today is, given that we're writing tests in whatever language, Java, C#, C++, Python, doesn't really matter, given that you're doing test-driven development, given that you're writing unit tests, how do we do this more effectively? How do we get the most bang for the buck? How do we improve our development process through testing? So why do we write our tests? Well, I know why I write them. Number one, because I want my code to work. If it isn't tested, it's broken. I actually found that out this morning. I was looking at some code in Cloud Tools for Eclipse, and one of our developers had proposed refactoring. I said, well, do we have tests for that class? Oops, looks like we forgot to test that class. So I started writing some tests for that class, and wouldn't you know it, I found a bug we didn't know about. And now I've got a pull request out for that. Still needs a little work. We also write tests because we want the code to keep working. Very many times when I make a change, when I send out a pull request, a test I wasn't even thinking of fails. So that keeps me from committing it. It keeps me from breaking the things that already work. It's also important to write tests because I want to write code faster and with fewer regressions and more confidence. Sometimes people say, we don't have time to write tests. We have to just, that's great, we'll do that later. My answer is, I write code a lot faster and I get to production a lot sooner when I'm writing tests at the beginning. It actually lets me move through, it lets me see the mistakes immediately rather than seeing the mistakes down the line where they're much harder to fix. It also lets me understand my code better in terms of what I'm doing. It lets me think about the code. It speeds up my development. It sounds counterintuitive. You're writing twice as much code, but you can do it in half the time if half of the code is tests. And of course, we write tests because we all make mistakes all the time. None of us write perfect code. I am constantly amazed how many times I write a test for a method that's too simple to fail, and wouldn't you know it, the test fails. And there's something I didn't understand about that method. It's not nearly as simple as I really thought it was. Even basic methods like set foo string s, this dot s equals foo, those can fail. Now, I'm going to begin with what I think of as the fundamental principle of unit testing in any language, in any framework. This is something, though, that is often sort of missed. What is a unit test? At its base, it's this. It's a piece of code that verifies that a known fixed input produces a known fixed output. Known and fixed are very important. You want to avoid any cases where you're trying to parameterize your tests too much, where you're sending in random data, where you're sending in time. If you have a method, for instance, that tests the square root function, test the square root of 9. You know what the square root of 9 is. It's 3. Don't test the square root of 17. You don't know what that is. Don't test the square root of 2. Maybe a few people know that to about 4 decimal places. Anybody know it beyond 4 decimal places? But you're still worrying about round-off error and things like that. Try and aim for, the test says, here's the input, and you want to test where you know the output, where nobody's going to argue with you about what the output is. That's your first test. Now, sometimes you don't genuinely know the correct output. What you do depends on the nature of the problem. In some problems where it's just some weird string coming from somewhere, but it's consistent and reproducible, always be the same thing, write a characterization test. Write a test that says assert equals, or whatever in your framework of choice, foo expected.getValue. And then the test will fail, but you will get the actual value out. On the other hand, a much trickier problem is when you're writing code for a sort of fuzzy area. One thing I deal with sometimes is clustering problems, where you've got a bunch of points in space and you're trying to divide them up into clusters. And it's not really always obvious what the right answer is. There may be more than one reasonable answer. You've got points in the middle that could go over to here, to cluster A or cluster B. How do you set them? What's correct, what isn't? Don't test that. What you do instead is you write input data where it's really obvious, where in the case of clusters, for example, you've got points that are very close together over here and points that are very close together over there, nothing in the middle, and then you make sure that you get the clusters you expect. If your input data doesn't give you clear and obvious output, expected values, find input data that does. That's really the trick. But in all circumstances, known fixed input and known fixed output. Anything that's going to make the input or output contingent or dependent, you want to avoid. You should never, for instance, generate random input. You may want to do fuzz testing, but that's a very different thing. And even if you do fuzz testing, you need to carefully record what values you fuzzed with, or you can't actually fix problems you discover. So always use fixed values for unit tests. Very controversial point, I prefer not to use named constants that come from the model code. If the model code has a named constant like webinf folder location, I won't use that static final field in my test. I'll just use the string literal. This gives me an ability to test if the named constant is actually incorrect or if it changes. I don't want changes in my model code to automatically change the tests. I want to know when the tests change. I want to know that the changes are deliberate. Other things that can be problematic because they make your input not known. That would include any sort of network access. This is a mistake I've made in the past myself. And preferably not the file system. You can probably get away with the file system if you need to, but it's a little flakier than in-memory access. And then the final thing I'll note is if you depend on something in the environment, the time of day, the speed of light, the gravitational constant of the universe, I don't care. The geographical location where the test is running, that most often sneaks into our tests in an unexpected way through time zones or default character encodings. Don't let that control the output of your test. If necessary, inject these values, inject a clock into your test, inject the gravitational constant of the universe, whatever it may be, so that you're not dependent on these things that are outside of your control in the environment. That's going to make your tests a lot more reproducible and a lot more debuggable. So that's point one, known fixed input, known output. Number two, write your tests first. How many people here generally write their tests first? More often than not. Okay, how many of you write the model code first and then the tests? Okay, about half and half. If you're writing the model code first, you're slowing yourself down and you're not getting as good a test coverage. Test first development is not just about testing, although that's part of it. It's about software development. When you write your tests first, you're thinking like a user of your library, of your class, of your code. Therefore, you create better APIs. You tend to create the APIs you need. You have fewer public methods, more private methods. You separate your interface from your implementation more cleanly because you don't even write the implementation until you've written the interface. It starts with the user rather than the used code. It makes your one common criticism of unit testing and high coverage is that, well, now if I need to change something in my model code, I need to change all these tests too because they're going to break. That's only going to happen if you've coupled your tests tightly to your implementation. If you wrote your tests before you wrote the implementation, they're only coupled to the API. And yes, if the API changes, then your tests are going to change too. That's just going to happen. But it gives you much less brittle code, much less brittle tests that don't need to change as often when you write the tests first. It also makes for better tests. Okay, so here's a very simple test class in Java for a list. Who here sees the bug in this test? Anybody? There's a bug in the test, not in the model code. The model code is standard java.util.list. It works. Okay. I'll tell you something else. I wrote this yesterday. This morning I was looking at this slide and going, damn it, I know I put a bug in here. Where's the bug? If you write your test first, you will find the bug in this code. You will find the bug in this code almost immediately. If you don't write your test first, you won't. I'll give you a hint. This code is only buggy in JUnit 4, not in JUnit 3. Does that give you a clue? Yes. Is it asserting the size of the list before the addition? No, it is not. Is it not asserting that the size of the list, sorry, that the value added is not in the list? It's not doing that, and it should, but nonetheless, that is not the bug here. Yes? Is it that I defined the list outside the method so I don't know how many times it was called? No. There's only one method in this class, and we'll get to that. But even if it was called many times in other methods, that would not cause the test to fail. Yes, in the back. No test annotation, thank you. And I can't tell you how many times this has happened to me where I've said, I find a bug in production, I think, damn it, I thought we had a test for that. And then I look at the code, and for one reason or another, including this one, oops, the test wasn't actually running. Now, how does test first development fix that? When you write your test first, you run the test first. Before you write the model code, you make sure the test fails before you write the code to make it pass. And if you write a test and you run the test, and the test passes before it's even failed, before you've even written the model code, something's wrong. You know, maybe you forgot an annotation, maybe there's some other problem. But this one has bitten me repeatedly. At least once every 2 months this happens to me somewhere in some code I'm dealing with. So that's another reason to write your tests first. Okay, that's number 2, write the test first. Number 3 principle for effective unit testing, I should have put numbers on my slides. Unit tests, and why unit tests in particular as opposed to fuzz tests or integration tests or manual tests or behavior tests and all that sort of stuff. Unit, of course, means one. Each test tests exactly one thing. What a test is depends a little bit on your framework. If you're in JUnit, basically each test method, each method with an test annotation or begins test, that is a single test. Not a test class, but the method. In other frameworks, it can be a little different in terms of what constitutes a single test. But every test method is one test. Best practice that is often observed more in the breach, one assert per test method. Each test method makes exactly one assertion. And if you want to set up your list and then assert 10 different things about that list, the way JUnit at least expects you to do that is you have 10 different test methods, and they can share the same setup code to set up the list. And that makes debugging a little easier. It lets you see what's actually broken and see how much is broken when you run your tests, as opposed to a sequence of 10 tests where as soon as the first one fails, you get no information from the following tests. So one assert per test method. Share the setup in your setup method or your fixture, whatever that looks like in your language of choice. Something that is often forgotten is you do not need to have an exact one-to-one ratio of test classes to model classes. It is perfectly okay that if you have one model class, dialog frame buffer or something, that single model class can have 10 different classes that test different components of it. Generally, they will set up the class differently. So that, I would say, in a lot of code bases, we see not enough test classes. We see too much crammed into a single test class, and that means that you've got a lot of setup code in each class that only applies to half your tests in the class, a quarter of the tests in the class, one test in the class. Even more important, though, unit test means independent. The individual test methods can run in any order. The input to one test does not depend on the output of the previous test. And test runners in practice do reorder tests. There's no guarantee what order your tests are going to run in. Generally, if you're running in Eclipse, if you're running in Travis or Jenkins or something like that, and you don't change your JVM and you don't change anything else, it's probably going to be the same order from run to run, but then you pass the code to your fellow developer on your team, and they're going to run it in a different order. And then you upgrade your JVM from 1.7.0.49 to 1.7.0.51 or something like that, and your tests start running in a different order. So if there's any order dependence, it can bite you, but at unexpected times. So watch out for that. Tests in some test runners run in parallel in multiple threads. There's no guarantee that they are running in a single thread. So tests should not interfere with each other. That's really important. Keeping in mind that the tests, even beyond the model code, may be running in multiple threads, try not to depend on synchronization or semaphores or any sort of special data structure. This can run into deadlock problems. Most importantly, though, don't share data between tests. The way this usually happens, if you have non-constant static fields, anytime you see a non-constant, if you want to put in a constant final static string or equivalent in your test, fine. But if it's some sort of mutable object like a list and it's static, or it's just a static int that different tests are reading and writing to and it's not final, watch out. That is almost guaranteedly a bug. That is one way to couple two tests together so that they depend on the order in which they run. Beyond this, an even harder nut to crack sometimes is if the code itself, the model code under test, has some sort of shared global state. You may not be able to fix that in your tests, but you need to watch out for it. In our project in Cloud Tools for Eclipse, we're dealing with Eclipse a lot of the time, and it has, for example, exactly one workspace. And a lot of our bigger tests have to set up a workspace and projects. And if those projects or workspaces are shared between tests, well, then we're in a world of hurt, because Eclipse shares a lot of global state just in the model code, even before you get to the tests. You can't necessarily avoid that, but you do need to worry about it. I think I said those next 2 points. 2 least known facts of unit testing. This will answer your question from earlier. Number 1, I said static state. Shared instance data, perfectly fine. Is there a bug in this class? Yes? Right. No. That is the common misunderstanding, at least in JUnit, every test method, test add and test add two elements, the test runner creates a completely new object for each one. So they have two different list fields. The test object itself is not reused. The test class is. It doesn't reload the test class with a new class loader. But if you run this, this test will pass. Both of these test methods pass, no matter what order they're run in, even if they're run in parallel. And that's simply because one is run with one object and one is run with another object. So I often see people in JUnit at least putting code in the setup method that doesn't really need to be there because they don't understand that separate test objects are used. So this is a neat trick that makes your code a little simpler. And then I said this before, number two, you can have many different test classes per model class. And it's the, I see a typo now, oh well. It is the fixture, the setup method really, that distinguishes whether you need a new test class or not. If you're going to change your set, if you've got 5 tests that set up the database in one way and 5 tests that set it up in a different way, that's 2 different test classes. Database testing is a whole nother talk. Okay, speed of tests. How fast do you want your tests to be? Your entire test suite for your product. As fast as possible. Sometimes that's not fast enough. I mean, we're having that experience with Cloud Tools for Eclipse where it takes on the order of 10 to 20 minutes to run the entire test suite. I would say that's too slow. We'll talk about what you can do about that. But any given test, any given single test or test class, a second or less, so you can run it very quickly in your IDE when you're developing, get a very fast feedback cycle going of tests, see the failure, fix the bug, run the test again, oops, it still fails, you didn't fix the bug, fix it again until it passes. So the individual tests ought to run in a second or less, 10 seconds maybe if you have to. A complete test suite, probably a minute or less. If it's going to take longer than that, start separating your tests out into multiple suites. Start by running the faster tests first. So if you have early failures or if you've just done something that breaks everything, you'll find out immediately. You don't want the incredibly long-running database integration test that takes 15 minutes just to set up the database to start before you've got your test for the set foo method if they're both broken. Might as well find the bug sooner rather than later. And the faster your tests run, the more frequently developers will run them and the easier it is. I will show you an example. This is something I fixed this week. Okay, did not actually swap to the tab. This is a pull request. And all this pull request did is you notice I took that integration test in pink there and I moved it down to the end of the list. And the reason I did that is the integration test takes approximately forever to run, and I'd rather the other tests run first. Plus, the integration test is flakier, and it fails for no good reason more often. So sometimes, if you've got particularly slow running tests, adjust your order or break them up so that you don't always have to run them. Okay, let's see. Presentation mode. Presenter. I think we'll get back up to full screen. Okay. General principle for testing. Passing tests produce no output. Or maybe just a green bar or single string, tests pass. That's all you want. If everything's good, they should be quiet. Failing tests can produce more output. They can produce log messages, they can produce debugging information, stack traces, etc. that will help you debug the problem. But you don't want that sort of detritus to come out of your passing test because it gets in your way of understanding what actually happened. This is something Maven and some other test runners get really, really wrong. because they just generate humongous amounts of output even when everything is okay. When's the last time you wanted to look at the log messages from your passing tests, when everything was fine and dandy? It's irrelevant. We don't need it. There's no reason to even generate it to the screen. Eclipse is pretty good about this. It doesn't show you a lot of details if things are passing. It shows you more if things are failing. If you've got loggers, you may want to silence them in your test. Set your logging level to no logs at all. But yeah, and avoid things like system.out, println, system.error.println, any sort of output like that. Even redirect that unless you're specifically testing it. Failing tests, those we're interested in. When's the last time you wanted to see the logs and the stack traces and every other piece of information you could find from a test that failed? For me, that was this morning. So clear, unambiguous error messages, you can help this by giving good assertion messages in your tests, maybe not to every assert method, but if something fails and you're not understanding it, make the assert method more descriptive. Another technique that's really important, rotate your test data. One problem I often see is every int in a suite of thousands of tests, the expected value is set to 3. And then when you see, oops, this was supposed to be 3, but it's really 17, it's not as immediately obvious where the problem arose. Furthermore, sometimes you have problems that arise with like 3 and not with 17, or vice versa, in deep parts of the code. So just pick new values for each test to the extent that it makes sense and the extent that it's possible. If you've got ints, choose different ints. If you've got times that you're testing, don't set all your times to midnight on January 1st, 1982. Move the months around, move the times of day around. This will both help you to identify the errors in the test and find new bugs you might not have found with a more restricted set of test values. Okay, flakiness. Yeah, this has been my bête noire lately. We've had some flakiness issues in Cloud Tools for Eclipse. Flakiness is when a test sometimes passes and sometimes fails. You run the test once, green, you check it in. And then the next time you run the test, suddenly it's red. And maybe it's not red because of the new change you made. Maybe it's red just because sometimes it passes and sometimes it fails. This is really dangerous, and you need to watch out for it. Try not to let it happen to you. What can be flaky? Anything that's time dependent, for example. Now that can be an explicit time dependence. I have seen, tests that failed across the New Year boundary, or tests that failed across the daylight savings time boundary. I have seen tests that failed because of leap seconds. But it can also mean that it's timing dependent. In particular, if you have some sort of GUI test that's bringing up your application, clicking buttons, moving dialogues around. If things run just a little bit faster, maybe the dialogue isn't up when you're trying to click a button in it. So sometimes it passes, sometimes fails. Selenium tests, same exact problem. Anyone here using Selenium or WebDriver? Yeah, so generally GUI tests by their nature tend to be a little flakier, and we need to watch out for that. And sometimes we play games like, well, we run it actually 3 times, and if it passes any of the 3 times, we call it a pass. But better yet, if you can avoid it, failing in the first place. Network availability is another source of flakiness. If your tests are talking to the network, then I have some tests in XAMPP that went out and loaded external schemas from very so-called authoritative sources, like the schema perhaps for the for Java server pages from Oracle. Except when I wrote it, it wasn't Oracle, it was Sun. And eventually Oracle bought Sun, and Oracle changed all the URLs of everything, so anything that pointed to sun.com no longer worked. For a while it redirected and then didn't even do that. And suddenly my tests broke. Code didn't change. Code hadn't changed for months. But my tests broke because I was depending on external network resources. Where she had external network resources I did not control. So that's something to watch out for. Explicit randomness. This is a really bad idea. If you see in a unit test math.random or the rand function in C or anything like that, watch out. Big warning flags should go off. Sirens, klaxons, alarms. And then the really nasty one, multi-threading. If you've got anything in your test that are happening because of race conditions or that depend on things to happen, this is, like anything involving multi-threading, it can really be problematic. We've had some of these issues in Cloud Tools for Eclipse where you're looking at the output of a test and it failed because a certain variable is null in a certain place, and you're walking through the code and you are absolutely convinced there's just no way that variable could be null at that location. It was already dereferenced 2 lines before. Just, it could not have happened like that. It's utterly impossible. That's a big sign that you've got a threading issue. And then worse yet, if that does happen to you, take your screenshots, take your stack dumps immediately, record everything, because the next time you run it, it's going to pass. And then it's going to pass 20 more times, or 2,000 more times, and then it's going to fail again. And those bugs can be very, very hard to track down. And usually, if that's happening in your test, it's happening in your code too. It's a real bug, your test has found it, but your test is not going to find it each and every time. So you need to figure it out. You need to understand how you need to synchronize your model code so that that does not become an issue. Yeah, those are the scary ones. That's the ones they pay us the big bucks to. System skew. This is a different kind of flakiness. Sometimes you'll have tests that just pass all the time when you run them, but then you pass them to someone else on your team, and they run them and they fail immediately. And every time they run them, they fail. Or maybe you send them off to Jenkins or your continuous integration server, and they fail there. What's going on? Maybe it's because I'm using a MacBook and my teammate is using Windows and Jenkins is running on Linux. And there can be subtle differences even if you're writing in Java, more so if you're writing in C or C++, between these different environments. Sometimes it's just threading issues. Sometimes it's assumptions about the underlying operating system, like is the path separator character a forward slash or a backward slash or a colon? Who remembers what operating system has a colon as the path separator character? Nobody. Oh, okay, one person, yeah. Mac OS, pre-Mac OS X. Not really relevant anymore, but these things happen. You can also have, not as much in Java, although there too, you can have some undefined behavior. Floating point round off can be an error. In early versions of Java, all VMs were guaranteed to give you the same answers for all floating point calculations. However they rounded off, it would be the same. That is no longer true and hasn't been so for years. So I may take the square root of 2 and get a different answer than you do when you take the square root of 2. Integer width in C is a long 8 bytes, 16 bytes, 4 bytes. That varies. Here's a big one that applies in Java as well. If you depend on the default character set, then my code that uses Greek letters may pass, and your code that uses Greek letters may fail, because we're using 2 different character sets for reading data. That happens occasionally. It's one reason you probably shouldn't use the default character set ever for anything. You should always specify your character set, and the character set you specify should always be UTF-8. But if your model code doesn't do that, you may get some test flakiness as a result. So this is all as a result of different kinds of operating systems. Generally, these problems often indicate real bugs in the model that need to be fixed. They just may not be apparent from a single run on a single developer's workstation. Another anti-pattern to watch out for: conditional logic in tests. If you see for loops that iterate across every element of a collection are fine. But if statements, if x is greater than 5, we're going to assert this, else we're going to assert something else. That should be 2 separate test methods, not 1, with different input values and different setup. When you see something like this happening, the risk becomes one or both of these are not actually executing. You may not be testing what you think you're testing. You may not be getting the coverage you need. It is very easy for these tests to not actually run when conditional logic sneaks in. Try and make, again, remember that known fixed input, known fixed output, and no choices in the middle. Okay, development practices with tests. Debugging. This is easy. If you find a bug in your code, it's shipped, it comes in from a user report, or a tester reports a bug, or you just happen to notice something, stop, think, don't fix the bug. File the issue, write a failing test. Make sure that test is read. Make sure, and once you think you understand the bug, you can write a test that addresses it, you run the test, and as often as not, the test passes and it's green, which means you didn't really understand the bug in the first place, or the bug isn't where you thought it was, or maybe the test doesn't really expose the bug. So whatever of those are true, you iterate on the test until you finally get a failing test that says, aha, now I understand the bug, and then you can start fixing it. And then, when the test goes green, you know, I can stop now. I fixed this bug. Furthermore, since the test becomes part of your test suite, you're running for the rest of time, the bug should not reoccur, it should not regress. Or if it does, it will be caught immediately before it ever gets checked into the repo. So for debugging, always get that failing test first. Nothing drives me nuts more than when, a bug gets assigned to a developer and then I get the code review and, here's the fix for the bug and there's no test change anywhere to be seen. Because even if I go ahead and then ask them, okay, could you please write a test for this bug? How do I know that the test really actually addresses the bug? Maybe it's just some sort of random change. Please write your bug tests first if you write nothing else first. This is a slide I added this morning because I was working on some refactoring. Break the code before you refactor it. In the specific case I was looking at in Cloud Tools for Eclipse, we had about 8 different methods to create a folder scattered throughout the code base, and we wanted to combine them into one. So I looked at some of the places where it was covered, where these different methods were used. You like code reuse, you don't like duplicate code. And I said to myself, I'm not sure this class is tested. So I took one of those methods to create a child folder, and I commented it out. And then I ran all the tests, and wouldn't you know it, they were all green. So what does that tell you? That tells you we're missing a test somewhere. And in particular, we were missing a test on the code we wanted to refactor, which is dangerous. So I said, okay, let me first write a test for this before I go ahead and refactor it and make it pass. And in the process of writing that test, well, what did I tell you earlier happens whenever you write a test for untested code? You find bugs. Wouldn't you know it, I found a bug. There was a bug in this untested class, which I am now halfway through the process of fixing. So that's why we write our tests. If for refactoring, as well as just trying to deliberately break the code and making sure the tests still fail, if you're measuring code coverage, which I recommend, you can look at your graphs. You can see, is this line at least covered? That doesn't guarantee that you've really got a test, but it's a prerequisite. If the line is not touched by the tests, then it will not be covered by the tests when you refactor or do anything else. If you have to, write additional tests before you perform any unsafe refactorings. I mean, there are some refactorings that can be done automatically by tools like renaming a variable, but in this case where we were trying to combine 8 different almost but not quite copy and paste create child folder methods with slightly different signatures, that needs some more thought. Other development practices. Who here is using continuous integration? That's good. 10 years ago, I wouldn't have had so many hands up. If you're not, start. If you're on GitHub, if you've got a public repo, you can set it up for free with Travis. It's really easy. Or you can run your own Jenkins server. There are other options out there. But basically, every time a test goes into the repo, a code goes into the repo, all the tests are run automatically and a report is sent out. And if you break something, the email goes out. Better yet, the tests are run before the code is merged into the repo. Ideally using a submit queue. Anybody here using a submit queue? Okay, this is less common. I don't see any hands going up, which is less than I would have thought. In a submit queue, you never directly commit to the repo. You never directly merge your own code. Instead, what you would do, you send out the pull request, the continuous build server merges it into a branch, it runs all the tests, and if and only if the tests pass, it will commit to the repo. And that guarantees, mostly aside from flakiness, that no breaking changes get into the repo. Because otherwise you still have the problem where people are supposed to run the test and they're supposed to respect the output of the continuous build server, but they merge anyway or by accident and things happen. So if you're using a submit queue, you're ahead of probably 99% of developers. Strong principle for your development teams: never ever allow a check-in if a test is failing. I don't care if it's a P0 production emergency. If a test is failing, that code does not get checked in. If it does happen that a a pull request or a change list gets accidentally merged and breaks things, or maybe it was flaky and broke things, maybe it went in and it passes every other time, roll back first, ask questions later. I am assuming everyone here is using good source code control like GitHub or equivalent. So don't try and send out a patch for it. Don't try and do an emergency fix. Roll back. And then you can fix at your leisure. Because there's nothing worse than you send out a patch and the patch doesn't fix it and makes things worse. And it just cascades. If your tests are read, no merges into the repo until the repo is fixed. That's a very strong principle. Okay, final thoughts, and I think we'll have time for a few questions. Most importantly, write your tests first before you change the model code. Make all tests unambiguous and reproducible. No flakiness, no randomness, no dependence on external environmental conditions. Use a continuous build server so you can keep your tests green. And with that, if there are any questions, comments, thoughts, whatever that you may wish to share, we're asking people to go to the microphone because this is being recorded so that your question can be heard by everybody and get onto the video.
Yeah, I wanted to ask the thing about writing the test first, because in my experience, usually because I actually have trouble writing the test first, that I usually find it more useful that you have that tight development cycle or iteration where it's like I write a little code, or write a little test, then I write a little code, then I write a little test, and
Sure.
I find that's usually really the big payoff.
Well, the tight development cycle is really important. What I would just suggest is try it. That write a little code, write a little test, write a little code, write a little test. Just throw out the first step. Write a little test, write a little code, write a little test, write a little code. It can be easier or harder depending on the nature of the code. The more library-like your code is, the easier it is. If it is sort of that functional input-output style, that's very easy to test. If it's something more along the lines of this code is bringing up these dialogues and configuring things in a certain way, that's a little harder. But the real key is the real problem people run into is they try and write too big a test chunk at first. So if I'm trying to write a test for, I don't know, create configuration method or something, my first test is going to be public void test create configuration, app engine libraries, dialog equal new app engine libraries, dialog.create configuration. And that's before I've even written the create configuration method. Then I get a red squiggly underline in Eclipse, and I'll use a quick fix, and it'll create the method for me. And then I'll say, okay, I think this method is going to need a string argument. So I'll put a string argument in my test. Again, compile breaks. I don't even need to run the test. Red squiggly underline, quick fix, and goes the string argument. And then I'll try and think about, okay, what's the next most immediate thing that it can do? What if the string is null? Should it throw a null pointer exception or not? Write the test for that, write the code. then it becomes a question, what else is that method doing and how easy is it to test? Now, if it's a method that's supposed to take input and give me a fixed output, we're good. Because that's very easy to write a test for. I just assert.assert equals expected value, test object.getValue. And then I can write as much model code as I need to make that pass. Sometimes that's just return a fixed value, and then I have to write another test. Sometimes it's something more. But it can be a little tricky if what you're really testing isn't exposed as a return value. If it's more of a void method, then you may be trying to call other methods on the object to inspect the object's internal state. You know, if that happens and you need to write the model code to understand what's really going on, okay, but try and write as much of the test first as you can. And then I'll say something else. If you're not writing your test first, you really, really have to measure your code coverage. Because if you write your test first and you're religious about it, you get 90% plus code coverage trivially. It's really, really easy. If you don't write your test first and you don't measure your code coverage, you're going to have a lot of untested code you don't know about. And that's dangerous. That's where the bugs lie. Okay, other questions? Okay, if not, yes, one more microphone, please.
I have the same problem as the previous question, that I think in code and not in tests. What do you think of tools like Cucumber for getting us started with a bunch of tests first and working from there?
What do I think about tools like Cucumber? Honestly, I don't think much about tools like Cucumber. I've never used it, so I can't say a lot about it. One thing I like about test-driven development is because it is focused on the code. The tests we write are code. And if you say you think in code, not in tests, do you think in terms of implementation or interface? Because you think in terms of implementation. So really, try thinking about the interface, because that's really what you're testing. And then if you have a list interface, we don't really care if it's an array list or a vector or some other weird data structure, if we get the interface right, and we can actually swap them out. So, and it's okay to think about the implementation. You just don't write the implementation until you've got the interface in place. One thing I discovered when I was doing XOM is I wrote a lot of designs for implementation. I discovered a lot of that I didn't actually need because there was no interface corresponding to it. If we write the implementation first, then you tend to expose the implementation in your interface. You have methods you don't need. You also have brittle code that's hard to change and hard to refactor when you need to. Okay, I think we may have time for one more. If not, thanks everyone for coming. I hope you have a happy rest of DevOps.